Okay, we're going to have a quick look here at the 2018 question 4. Now I know recording the screen comes out all interrupted there, or flickery or whatever, but just a quick look at the question first. Now something we don't talk about a lot, but I want to start this question up high on the page. Now I know that the cone part here is 35. And then the cylinder part is 85. So that's where the elevation is going. And because the height is 64, I came down there something like 90 or there. So, but I've still kept it up tight to the corner there. So my elevation is going to fit in here. So when I come over, I want to start by drawing the end view though, and I'll just explain why there now in a second. So the radius of this is 64, so the center is going to be up 32. So there's my center line. So I'm going to just draw that circle there now. And the smaller circle here then is 32, which is 16 radius. So I'm going to just draw this as well. Now it's an awful lot more accurate to draw the circles. I'll just mark in the dotted lines here with a pencil. Now if I had a sharper point on my compass, I probably could, but it's hard to do good dotted lines with a compass. So that there is the body of the cylinder. Now it's just a lot easier to draw the circle there and bring this across. Because otherwise, if I did the cylinder first and I'm trying to project over, often there the center won't work out right. You'll be a millimeter and a half out. It's very difficult to get it accurate. So I just find it's easier to draw the circles and project them across. So there's the cylinder. Here's the cone. Just bring it across the base of the cone. And just looking ahead here, I'm going to project this down and find the apex O of the cone, because I'm going to need that later as well, but that's going to be later. So here is the cone part, heavy that in plane. I'm going to project these down. Now there's a little cut taken out at the end of this here, over 15. So it's heavy, the rest of the way is over here. 60-degree angle. And that's why over in the in view here we have this dotted line running along there. So I'm going to draw my plan next. Grab 45-degree set square. Just put down my 45-degree line there now. I don't need such a big gap between them, but like I could put my 45-degree line down here, but I'm going to just move that 45-degree line over there. It'll just condense the space a bit. So so I'll just adjust the camera here now a small bit. So there's the cone. Here's the base of the cone. The next line in is the body of the cylinder. And the center line, which I'll just bring across as well. Okay, so if this was a full cylinder, obviously the question would be a lot easier because this would be just a rectangle, but it's not. So anyway, what I am going to do here though is I am going to extend this down here, and I'm going to pretend that it was a full cylinder. Okay, which means that my cut section down here is going to be an ellipse. So we're going to have an ellipse here, and I'll just project down. The key points here would be coming from the center line here. That would be the ends of the major axis, and this would be the ends of the minor axis. Now I could go and draw an ellipse there using circles, but it would be very small, so I'm going to just break it up in the end view here as a full ellipse. So just put on the equal divisions there, 12 equal distances, using the 30/60. And I'll project them back across then. I'll do this a little bit heavier than I would like to now, so you can see what I'm doing here. Now it seems that these are just coinciding here now, and I broke this up, that my flat section here is coinciding. So I'm going to throw a few numbers on this as well, just to help people understand it. So I'll just number that 1 to 12. So there's 4 up on top, 3 and 5, 2 and 6, 1 and 7, 12 and 8, 11 and 9 and 10 would be the bottom of our ellipse if it was a full ellipse, which is not, but we'll deal with that in a second. So that would be 10. That would be 4. So I'm going to project these over now and down. So dealing first of all with 2 and 12. There's a point here. And a point there, down from 2. So then 3 and 11, 3 is here. And 11 projected down is there. So that's half of my ellipse. Now again, I could use symmetry, because that's a mirror image, the top half there. I could just use those points, but I'm going to just keep going with my divisions over here. So 5 and 9, 6 and 8, bring them across, and bring them down. So 6 and 8 and 5 and 9. So that would be the full ellipse here now, but I don't want all of it. Okay, I don't want all of it, because that ellipse would have been finishing here at 12 and 8 for me. So it's finishing here. There's my straight line, and I now can heavy in the remains of the cylinder over there and the cone. Often if a cylinder or a cone is cut, you're better off to pretend it wasn't, work with the full thing, and then deal with the cut part afterwards, and we will see that in a minute when we look at the developments here. So we've got our front view, our top view, our end view. So that sorts out part A, the elevation and end view, and part B, which was the plan. So part C was the development of the conical surface. So this here is the true length of the side of the cone, so I'll just highlight that in there. I'll just say TL. So that is the true length of the side of the cone. So that's what I was saying here now, that if we take that and we're going to develop this cone as if it's a full cone. So set your compass. Now I'll just zoom back, and I'll just operate over here now for a minute. So I want to put my compass anywhere really and swing an arc, but it's very important to mark the point, because it's easy to mistake where you've started your arc from. So we're drawing a full cone here, so I need to get 1/12 of the size of the cone here. So I'll just extend out one of these. So this distance here is 1/12 from there to there. And I'll just colour that in, I think, as well. If I can find a colouring pencil. Okay, so this here, that red distance here, that is 1/12 of the base of my cone. So I want to set my compass to that 1/12, and I'm going to start anywhere and just step off this. So again there, you just need to be careful. It doesn't matter where you start, but just put a dot to start, and I want 12 of those distances. 3. Now be careful now, you want 12 spaces, not 12 marks, which would only give you 11 spaces. 10. So I'll just count them again. 2, 4, 6, 8, 10, 11. So I'll put it on up here. So if it was a full cone, that would be the development of my full cone. Now again, that 1/12 distance is where these come from. I'll just mark one of them there. So that's my 1/12. And this radius came from the one that I put in orange there a second ago. I know it's off screen now. And finally there then, the last thing there then is, because this is not a full cone, I want to measure how far down from the top that on the true length there, the outside of the cone. So that's cut that far down, and I want to take that, bring it over here, put this in heavy. So the heavy then development of that is here. And I'll just heavy in the bottom of that as well. So that there's the development of the cone, which was A. Now, the next part of this then is, I'll just readjust the camera there. We want to draw the development of the cylinder, but the cylinder is cut. Now I kind of have two choices. Do I have room down here? Now it's going to be 3.14 times the diameter, so roughly 3 times 32, which is 90 or 100. So I will have, I do know I have room here now. An understanding of maths here is useful. So we know that's 32, and we know the development of 32 would be 3.14 times. So 332s would be 96, so I've got 110 there. So I'm going to just do it down here. But if I didn't, I would be drawing this, I would just take this part out and stand it the perpendicular there, just stand it up there, the cylinder, and work across the way here. But seeing as I have room, I will just do it this way. So if that was a full cylinder, that would be the end of my cylinder here, where I remember I marked the full thing here, but I didn't bother drawing it. You can see where that full cylinder would be. So again, I'm going to be setting my compass here to 1/12. So I might just mark this in a color as well to help you see it. So if I mark in this here in green, that distance there is 1/12 of the cylinder. So I'll set my compass to that. And I'm going to just start randomly down here. I'm going to pick a point because I know this is going to fit. So I'll just mark my 12 parts up here. And again, 12 spaces now, not 12 marks. 4, 5, 6, 7, 8, 9, 11, 12. Okay. So, if there was no cut, to the cylinder, that would be just a rectangle and we would be finished. But seeing as there is, I'm just going to put in these folding lines here are where I broke the cylinder into 12 equal bits because we're going to be using them in a second. Okay, so does it matter where you start your numbering here? No, it doesn't. It doesn't really. But because 4 is the shortest element of this, okay, I want to put 4 in the center. 5, 6, 7, 8, 9, 10. Okay, now you might wonder why is 10 there twice, but when it folds around, the two 10s become the same line when it's folded around. So I'm going to just project now down from either the elevation up above here or from the plan if I had numbered it all. So 4 is cut here, 3 and 5 are cut next. 3 and 5 are cut next. 2 and 6. 1 and 7. 12 and 8. Now again, if this was a full cylinder and there was no little angled cut on it, that would be the full development. That would be the full development. But we know that from 12 and 8 on, so from 12 and 8 on is the full height of it, so it just goes outwards from there. Heavy these in. And that's development of B. Okay, so just double checking there the question. There's the development of the cylindrical surface of B. So it said the cylindrical surface, so we don't need to worry about the elliptical cut here and the flat part that's left and all that. We don't need to worry about any of that. So that's it, finished. Hope you enjoy doing that.